All right. Hey, everybody. It's just about the time here. As we were saying earlier, we've got a little bit of a special guest. We're here. The museum's about to close down. It's up until 5 p.m. and it's currently 4:50 p.m. So we should have a little bit less volume going on. The good news is we're going to be using the time here to check out some cool new content. We have a special guest from JPL to talk to us about NASA Eyes on the Solar System. So without further ado, let us hop over with Mr. Kevin J. Hussey right there. So we are here. Can you go ahead and talk? Let's make sure the mics are okay.
3. Testing 1, 2, 3.
All right, chat. Let's give Kevin here a big warm welcome from KSA and tell us if you can hear us in chat. Is the audio nominal? Is everything sounding good? Because we have some cool things to check out. What sort of things do we have new in Eyes on the Solar System?
Well, Eyes on the Solar System is actually 3 programs.
Yeah.
Eyes on the Solar System, Eyes on the Earth, and Eyes on Exoplanets. So today we're going to focus on Eyes on Exoplanets because of the big announcement that occurred on Wednesday. And we had a first in the Eyes family. This Eyes on Exoplanets was used for the first time live to demonstrate features during a press conference.
During the press conference, y'all were ready for that.
Yeah, and we were happy to do that because typically they would use Eyes to either take B-roll or they would do animations. But in this case, because Eyes had all the information they wanted, they went with it live. So what that meant was I got to actually be at the press conference in the room, and I set up the computer. Well, I shouldn't say set up the computer. A guy named Sylvester did that.
Yeah, it's good to have help.
Yeah. But I went ahead and set up the software so that it would be absolutely ready for the scientist, Nicole, when it was time to do her part. And I will actually walk our audience through what I did, how to use the software, take them through basically what happened at the press conference. I can't talk a lot about the science because I'm not a scientist, I'm a technologist.
We're communicators and technologists, right? Yeah, exactly.
But I can show them how the technology was used to communicate the science.
Excellent.
How's that?
And we're all set up here, I think. We've got the latest version of Eyes on the Solar System. The trick is it's free.
Yeah, it is free.
Isn't it? It's free. So yeah, it's like, oh, that wasn't a setup or anything. Really, Kevin, tell me how free it is.
It is quite free.
It's about as free as free can be.
You got to understand, it's free unless you paid federal income tax.
So
what I like to say is, it is no additional cost to U.S. taxpayers.
To U.S. taxpayers, nice.
But I do appreciate you paying your taxes.
We actually have some links in chat, so if you want to download a copy of it, you can watch the show, you can listen along, you can run it on your own computer.
Absolutely.
It's on PC, it's on Mac.
Mac and PC. It's eyes.nasa.gov.
Got the link right there in chat if y'all want to click.
Go ahead, you download it, install it just like any other video game.
Excellent.
And then you are able from there to pick and choose whether you want to focus on Eyes on the Earth, Eyes on the Solar System, or Eyes on Exoplanets.
Yeah, there's a little like a chooser window that comes up.
That's right, there's a window to pick. And so today, we're going to start by focusing on Eyes on Exoplanets because it was the star of the show on Wednesday at NASA headquarters.
Excellent. So can we hop over and start checking it out?
Let's do it.
All right, so let's switch on over. That is the wrong place. There we go. That's what we want to see, right?
Okay, so that's on screensaver. It'll go back to the
thing. So I'm going to go ahead and get this off now that we can see that correctly. And away you go. That is your control if you would like to drive us around.
All right, I'm going to drive you around.
Excellent.
So first, I'll introduce you to the window and basic controls.
Okay.
The most basic control is to click the left click and drag.
All right.
Okay. So now it's back to the home, and I'm going to left click and drag to move us around the center of it's basically around the center of our solar system because we sense things from there.
Yeah.
Okay? So click and drag, and you've got a scroll wheel on your mouse.
Right.
And if you scroll in and out, you can zoom in. I'm going to scroll all the way in, and keep scrolling. You'll see our solar system come into focus here. There it is.
There it goes. Oh, some spacecraft as well. Some Voyagers, Pioneers.
So we are here at our solar system.
Yeah.
Moving around, and then when you click the home button, this will take you back out to a distance of about 1,000 light years from Earth. So you're at 1,000 light years, scrolling around. So click, drag, and scroll is the main functionality. Now, what are you seeing on the screen? So every one of these highlighted stars represents one of the 2,577 stars around which we have confirmed exoplanets.
Wait,
right? So
those are the ones with confirmed exoplanets? It's not just all the stars, that's confirmed
Those are
exoplanets?
confirmed exoplanets are 3449. Now, you're gonna notice that right away that there's this big cone of exoplanets out in one direction.
Yeah, I see that.
Right?
It's like we were looking in one direction or something.
Well, the Kepler telescope
Yeah?
was staring in that direction. We'll get to that in a minute. Let me go back to my controls, right?
Okay.
So first thing is, anything that's highlighted like this is a star around which we've discovered and confirmed exoplanets.
Yeah.
These are all existing in the Caltech NEXI, which stands for NASA Exoplanet Database, which is housed down at Caltech.
Right.
Right. And every night we go out and we search for new data in this database.
Yeah.
So this number can change every single day.
So y'all, like NASA Eyes does, is that the right term?
Exactly.
Y'all go out and get data every night?
Every night we get data. For the Earth, we get it 4 times a day, an update.
Wow.
For the solar system, daily, and for this, daily.
Daily.
All right? So we try to keep things up to date.
Wait, okay, so I have a question. There was the big press conference, right?
Yes.
Would that data have been in here before the press conference if someone knew where to look?
Yes.
Can you tell me? Oh, it was!
It was. We hit it because look, there's 2577.
Yeah.
You'd have to know exactly where it was. What we didn't do is we turned off this highlight.
So it would take you into it like the cheat sheet or the shortcut.
Exactly. It takes about an hour for it to propagate from JPL up to the Amazon cloud.
Yeah.
So when the press conference started, we went ahead and put this highlight up. So the easy way to get to it was click here, but it wasn't there when we started.
It wasn't there until...
So what I had to do was I went up here to the search function.
And you knew what to search for.
So I'll show you what I did. I just search by name.
Okay.
Because we knew the name of the system was Trappist 1.
Yeah.
Go ahead and type in Trappist.
2 P's, I think?
Yep. EST
Trappist
or
1.
ST, right? Hit go.
Just hit go?
Yep.
There we go.
And then I went in and clicked on Trappist 1.
Yeah.
So then it will fly us out to that solar system. And it will show. Now what they wanted, they didn't want all the planets showing up.
Yeah.
So what I did was I clicked on the star, so you zoom into the star.
Yeah.
And then we hid the window. So when it started, this is what we saw on the screen.
And I do like you've got the hypothetical visualization there too. Yeah.
That we have no clue. Well, we have a better clue
have
what
some
the sun
clue.
looks
Yeah,
like.
yeah, exactly.
But these planets are all hypothetical visualizations.
Yeah.
We can't yet image planets around other stars.
Yeah, we know where they're. We know how
they're
far
there.
they are from the star and stuff like that.
Some of my colleagues are working on a new telescope that has a star shade
Yeah.
that will block out the starlight and allow you to image the planet right next to it.
Oh wow.
That's coming.
Wow.
That's coming.
And we'll be able to use that too.
We'll be able to use it.
Okay, so I totally sidetracked you with the could we have cheated on the press conference?
So the answer is this. Anybody could have done this.
Yeah, if they knew.
The morning of.
Ah, okay.
But they didn't know, so therefore, it was hidden. So now they started like this, and then the first thing that our scientists did, Nicole, she clicked on this and said, "Let's go to the planetary system." And then eyes would zoom out, show you the entire system.
Yeah.
Okay. Now, at this point, one of the things she wanted to stress was the fact that 3 of these 7 Earth-sized planets were in the habitable zone.
Right, the Goldilocks zone.
Right? So word for it. So I'm going to click on there. She went right here right away and put up the habitable zone.
And now, it overlays where the habitable zone is.
For some reason, we're missing it here. Oh, you can see it's something.
Yeah, I think it's the monitor actually, the resolution of the monitor. You can see it on there.
Oh, you can see it back
Yeah,
there.
you can see it on there. It's
Okay.
just the angle of the monitor.
It's okay. So you can see that. No, I'm fine now that I know that's there. Oh, there it is.
There you go. Yeah.
There I got it. So any of the planets that are in this aqua area, the habitable zone or the Goldilocks zone is where liquid water can exist on the surface year round.
Right.
So let's take the first one that's in the habitable zone, which is
Trappist 1E.
Like E.
All right.
I'm going to click on E, and we're going to do hypothetical visualization.
Right.
All right. So now you see this world. It looks like a water world.
Right.
And you'll notice that one side looks like it has an ocean.
Okay.
But the other side
is all ice.
Is all ice. Now the reason is this planet is
tidally locked
to the sun.
So of course only one side gets.
Only one side gets it. Therefore, you're going to have an ocean here.
Oh, that's cool.
Then the other thing is we made a big deal about being able to compare it to the size of our Earth. So I'm not being able to see it on the screen. This is a little bit chopped off.
Okay, it's too low.
There's a button down there that would say compare size.
Gotcha.
We're going to want to do that.
Okay.
Is there some way we can, I can't get to that control.
Let's see right quick if there's something I can do.
I'm sorry I didn't notice that earlier.
No, it's okay. We were running at a little bit of a resolution deficit here. Unless I can move this part, I don't think that I can move this around.
Oh, you can see it there? Oh, that's compared to our solar system.
Yeah, there's a button underneath it that's cut off.
To the planet. Oh, you know what? Hang on a second. This could be it's just.
Yeah, it's that. Because I'm kind of limited on the resolution here,
I
don't think I can get it any bigger than that.
But what we're doing now is we're comparing it. I'll wait till the noise in the background stops for a second.
They're announcing now that the museum has closed down. So again, I can talk over them right quick. Let's see. There we go. That was the announcement. All right, good deal.
All right. Now, you can see that this entire. I lost my mouse.
Yeah, it's on the other monitor. There you go.
The entire system fits within where Mercury would be for our system.
Right.
So here there's 7 planets. If our sun was in the middle, there'd be Mercury.
They're well inside the orbit of Mercury.
Inside. But because this is an M-class star,
right,
which means it is not nearly as warm as our star,
right.
So therefore, the habitable zone, which all of a sudden disappeared.
Yeah.
Right? I wonder what happened there, you know?
I'm not sure. It's very much the fact that, like, the application actually warned me that it was best in full screen, and I didn't have enough. It's not on you, it's on my screen real estate here.
Let me try this. What happens if I go out and back
give it a try. Let's see.
Now, what happened? What happened back here? Are you still okay?
You know something? That's fine. We can keep running it that way. We got some black bar. That's okay. We can run it that way. Yeah, we can run it that way.
Because now, if I go back to the habitable zone, see where it is?
Yeah, we're good.
Oh, we're good.
Yeah, we're good.
So then if I go in, so we did E, let's go to the next one. Let's go to F.
Okay.
This time it should show it. Oh, great. So see where it says compare size?
Right.
I'm going to compare size.
And it puts the Earth next to it.
Throws the Earth up. We did say that they were nearly Earth-sized, and we weren't kidding.
They weren't kidding. I mean, look, it's right there on the screen.
And over here you have, it is it's only 5% larger.
Right, it's a little bit larger, but the mass is less. It's a little bit over half the mass.
Okay. So you can do these comparisons. You can also compare for other exoplanets. As you can see, that Jupiter is.
Wow.
Right. Get the idea.
Yeah.
Right. Let's go back to Earth. Now, what's kind of fun to do is I'm going to go back to planetary system view.
Gotcha.
We're going to look at the whole system again. There's the star. We're going to zoom back out.
Yep, all the orbits and everything.
I want to give you an idea of kind of a fun tool. It's not documented, but it's cool.
An undocumented tool.
Right.
I like this.
So if you right-click on a label, see where it says click another object?
Yeah.
Let's go see how close the closest stars. When we click on the closest planet, it is. I'm going to move it out of our way here.
Yeah.
So it's less than 1 million miles.
Okay.
It's only 5 light seconds away, and it is less than 1 million miles. So the Earth's about 93 million miles from our sun. This one is only less than 1 million miles away.
Wow.
So how far is the farthest? Well, we'll do the same thing. We'll left click here. Right click, and we can see that it is.
It's 5.8.
It's only 5.8 million miles to its farthest.
That's such a. I mean, compared to what we're used to, you know, like the planets that we learned, that's such a small solar system, or small system.
It's a very small system. And so while we were here, again, the big deal was that these planets, 7 Earth-sized, all within this one system,
right?
And they consider this to be a nearby system.
It's 40 light years, I think, right?
Let's figure that out. So we have this button.
I just jumped ahead. I'm sorry.
You jumped ahead. That's okay. So we have this little button. How long to travel there?
Right.
So using an Audi. Traveling at 60 miles an hour. It's a mere 441 million years.
So that's a lot of time.
And a lot of gas. Takes a lot of gas. But as we know, a jet's so much faster.
A jet's a lot faster.
This will cut down the time. Something more palatable.
Yeah.
We'll see.
600 miles per hour.
It's only 44 million.
No big deal.
No big deal, right? Clearly, if we travel at the speed of light, we should get there in no time. 39.
39 years. Yeah. That's cool.
My last demonstration here in the museum, I had 2 young kids.
Yeah.
And I was showing them this, and we're talking about 5-year-old and a 6-year-old.
Yeah.
And they saw that they said, well, that's too long. We wouldn't live that long.
There you go.
And I said, well, how about this? So I put on the speed of light. It's 39 years. Yeah, I could make it there.
Yeah,
39.
you can make it there, yeah.
It was great. So the software, we designed it, again, for any age. It all works on button clicks.
Yeah.
Things are well explained, I hope. So for example, let's go back and I'll pick E again.
E again, all right. It's less complicated than Kerbal, let's put it that way.
Yes.
You don't even have to use the keyboard, really.
You don't have to. And of course, it doesn't do as much.
Yeah, yeah.
Hey, but, you give it something. And if you roll over and you click on it, there'll be some information about
the science from the observations that we had when we were confirming the exoplanets.
Right? There's some other things you can do. So
okay.
Home basically takes you back to the, again, solar system in the middle. Now let's take a look at this cone. All right.
That
so
cone
the
is
story
crazy.
on the cone is these are Kepler discoveries.
Right.
And so you're seeing what we call one of the best examples ever of observational bias.
Yeah, right.
The Kepler telescope. Okay, and let's take a look at it. These are the planet finders.
Okay.
Kepler.
Here's Kepler.
Here's what it looks like.
And it takes you down to Kepler. And it shows you where Kepler is right now.
Now look at that pattern. So that's the shape of the CCD. It was a staring device. It locked into a place in space.
Yeah.
Where it was looking at about 300,000 stars.
Yeah.
Cataloging everything it could find.
Wow.
So now, if we had pointed it in the opposite direction,
right,
the contention is we would have seen the exact same number. So scientists currently believe that any star out there has at least one planet.
Wow.
Most of them have multiple planets. All right, so that one had 7. We have 8, 9 if you're an old timer. at least 8, and many dwarfs.
And many dwarfs. Thank you.
At least 7
Look,
dwarfs.
a red car is still a car. Yeah, okay.
That was my art.
Thank you.
Yep.
See,
I would say it is a planet, a dwarf.
It's a dwarf planet, sure, but it's a planet.
Because people, I don't know what it is. Kids get really uptight.
They should. I mean, I'm just saying.
Yeah.
We're there with Pluto, guys. Can we get some Das H's in chat? Look, so one of my little icons that we have in chat is Pluto, and after we did the New Horizons flyby, we saw kind of the heart-shaped part, and so our heart in chat is the Das H, Pluto with a little heart on the bottom. Could we hop back out to the big cone view again, real quick?
I'll just go to home like this, or actually Kepler.
Yeah.
And you'll see some other things, interesting things. So go ahead.
The crazy thing for me with this is this cone is like starting down there at Earth, and then it kind of goes out in this one direction.
Yep.
And you said if they pointed that thing in the other direction,
yes,
it might look the same way.
Well, let's look at you see that
there's a couple other little rays almost. Yeah.
What happened was Kepler lost its ability initially to lock into one place.
Okay.
And so they had to engineer a way to figure out how they could lock it again, because the way it works, it stares.
Yeah.
Right?
It just sits there and just exposes the CCD to the light.
And it's looking for changes in brightness of about 300,000 stars simultaneously.
God.
Right? So now they figured out how they could do it again. So now they're looking in different locations. And look at this. They call this K2 mission.
Right.
K2. You can see it started looking that way for a while. Now it's looking in any direction it looks. Look what happens.
It just finds exoplanets.
They would get that same cone. The contention is, now I accidentally clicked on it.
Oh, that's okay.
Let's see what we get here.
It looks very cinematic. It's good.
Yes. Right. So this is another system. I just randomly clicked on.
It's got 3.
Let's go take a look at one of these. All right. Oh, in fact, I like to start by comparing it with our solar system.
Yeah, no.
And again, these are well within Mercury.
Yep.
Let's check for habitable zone. Whoops, habitable zone.
There's the habitable zone.
Darn.
So outside there,
they're too hot.
That's okay. There's 329,999 other options.
Yeah. So we're going to click here, and let's take a look. This will be a hot Jupiter.
Okay.
And of course, all we can do is do an artist concept.
Yeah, of course, because we can't visually image them or anything. So these are all sort of imagination based on the information.
But the data here is as accurate as we have.
Right.
We know that it's look how small it is. So let's compare this. This would be another Earth size.
Yep.
Or a little bigger than Earth. But it's a hot Jupiter.
It looks like a movie trailer. The hot Jupiter like graphic in the upper left. It's like hot Jupiter coming this fall or whatever. Like.
That'd be cool. Right? Now compare it to actual Jupiter. It's a baby.
This is a baby compared to the actual one. Yeah.
All right. So those are the things I like to do. Check for the habitable zone, and then of course how long to travel there.
Yep.
And I jump right to light.
Right to light speed. Yeah.
There's no sense. So that one's out there, 868.
And that's one of the reasons that Trappist was such a big deal, because it's 3940 away,
close.
right?
Relatively close.
Relatively close. It's not the closest one we've got, but it's close in terms of our celestial neighborhood.
So speaking of closest,
Okay.
working my way across the top here, we looked at some missions, but see the one where the Earth, so the view from Earth.
Yeah.
Now we're going to go to the surface of the Earth.
Okay.
Actually, here's the Earth.
That's a pretty sweet
Let me
Earth.
back up for a second. Let me back up for once.
Okay.
Or upside down. Look, there are 3 producers on this. Myself, Randy Jackson, and Michael Green.
Okay.
And when we were looking for a way to visualize the stars,
Okay.
we had 3 different choices. One was what you see here, which looks like
It's like a little compass
Christmas
point
star.
lens
Yeah.
flare almost. Yeah, Christmas star.
Christmas star. But we also had my choice, which was this. Now, I got outvoted. And
So you got outvoted for the default, though.
for the default.
For the default. Yours is still there.
It's still there. And I like to use it because what this shows me is the size of the circle indicates its distance.
Right.
The color indicates the star type. And
Right.
the number inside tells you how many planets are in that system. I felt this was a more interesting view, so I'm going to leave it here from now on.
No, it's fine.
All right?
You're in charge. Like,
All right, here we
hey,
go.
you won't get outvoted here. That's fine. We have enough lens flare in KSP sometimes. So.
All right. Now I'm going to turn the light off. So this is kind of where we are here.
Oh, and there's the ISS going over South America right now.
South America.
Yeah.
So now what I can do is I can click on anywhere on the globe. So I'm going to go someplace where it's dark.
Yeah.
Let's go to, all right, let's go near Lisbon, Portugal.
Okay.
So if I was in Lisbon right now, and I looked up at the night sky.
I love the cuts, by the way, how it kind of flies to the next
All right,
location.
okay. If you look around, these are the stars that have exoplanets up in your night sky.
Wow.
Now, I'm going to go ahead and say stars only visible to the naked eye, which
Sure.
will greatly cut down the number. And then to help you find where it is, I'm going to say show
Oh, there's the constellations, right.
So now I'm looking around, and I kind of like there's one with 6.
This one's 6.
So here's one here at the Little Dipper. See, so you look around, find something interesting, and then just click.
You just click on it. And
out,
there you go. It's going to
we
fly
take
you there.
You never know what you're going to get.
The cinematic camera fly there.
And here we go. And how big is it compared with our solar system?
The same.
now
Oh,
here we
there you go.
Here we go. Now this gets interesting.
Yeah.
So this one looks similar to ours. Right?
And we have this kind of time warped right now, right? It's
yeah.
This isn't real time. Earth is not.
This is 7 weeks a second.
Okay,
And
gotcha.
you can change that just by
You can
sliding
turn it
this.
down to real
So
time.
now
Oh,
it's
backwards.
Backwards, and then you can say real rate.
And that's
Real
like
rate,
1 to 1, 1 second per
and
second.
Of course, things aren't moving there.
Nice.
They are moving fast.
I wish I could do that in Kerbal. Just click real rate, and it would just make my
go
craft
normal.
run.
Yeah, it's 1 to 1. So I'm going to click it a little bit to give it a little bit of
Yeah, sure. Some motion.
just so there's some motion there to keep it interesting. And then now let's compare what we compare with our solar system.
Mm-hmm.
Now habitable zone.
We know where our habitable zone is.
Yep.
We're in it.
Ooh, one of them just its first planet
Yeah.
just is inside our habitable zone.
That's almost out there about where Mars was, if I looked correctly.
Let's
The
see
compare
let's
thing will
compare
show
it.
you, right? Just outside
Just
of Mars.
outside of
Okay,
Mars,
gotcha.
right, just outside of Mars. And so habitable zone.
Yep.
And let's go ahead. I'm going to click on it, take a look at it.
Zoom in again.
This will be another gas giant.
Gas giant.
Doesn't bode well for life there.
Right,
Otherwise,
exactly. Well, as we know it.
As we know.
I'm going to toss that out there.
Right? Yeah, as we know. Could be some odd gas.
Yeah, you never know.
So, and you notice every one of these is slightly different.
Right.
Because we programmatically...
You didn't just take the same thing over and over again.
We go ahead and we look at all the parameters in the database and then
Right.
say we assign colors and textures to
Right.
various parameters. So they all look a little different.
Gotcha. It's
All
almost like a
slightly-
procedural generation sort of thing, right?
Exactly.
You take some basic data and you
Yep.
spin it up.
Right.
Excellent.
But
More
you
realistic
notice-
than No Man's Sky.
But here, we do not have a comparison because in the database it doesn't have the regions.
Oh, it doesn't. It says unknown planet radius, so it's just
So
defaulted out to.
therefore, we don't know, so we don't show it.
So you don't show it. That's
don't show it.
fantastic. As opposed to
Right.
just whatever, we programmed it, just
Right.
leave it. It
So
actually disables the button.
We want to keep things as virtually real as possible, given this is totally
Yeah,
a
but it's
color,
still
something to look at, right?
it's made up. Yeah, but you wouldn't want to hop out there and have like, oh, here is a gray sphere with a couple vertexes on it, or
looks
whatever.
kinda
Like,
boring,
yeah, that's
right?
boring. Yeah.
So, all right, so we've worked our way down. So this was the view from Earth. We found one that had 3 planets. We
Yeah.
looked at it, and then of course there's the extreme planets.
Extreme planets.
So you could say, what are the largest? So let's go take a look at the largest.
Yeah.
Okay, so the largest
And these are confirmed exoplanets that we.
Everything in here
Right.
is confirmed.
It's confirmed exoplanets.
Absolutely.
So this isn't just making stuff
We
up.
aren't just making it up. This is all a visualization of that database.
Excellent.
Now, this one here, let's go ahead and compare it to.
So that's got the size data in
Right.
there, so we can compare
So
it.
I'm going to compare it first to the Earth.
Where's the Earth?
It's right there.
Whoa!
There it is.
It's that little. Can you zoom in any closer to it? Oh wow!
There's the Earth.
So
So now let's go ahead and let's put Jupiter next to it.
So this is our Jupiter
Our
versus
Jupiter.
yeah.
So that is
Wow.
one massive planet.
That is a big-
1,000 Earths fit in our Jupiter.
God.
So you can imagine. That's a big dude, right?
That's cool.
Right.
What other types of extremes are there?
All right, let's go look. We got extreme, we got largest, smallest, and weirdest.
Okay,
Yeah,
what?
Weirdest. Let's look at that. So in this case, this is 1.5 times the diameter of Jupiter,
Okay.
but it's only half the mass. So this thing would, if it were styrofoam, it would float in water.
Really?
Yeah. So I'm gonna turn the light on. It is odd. Oops. I turned it off. Sorry.
Yeah, it may be the
Again, it's the angle of the.
yeah, maybe the monitor there.
Turn on. So-
you can kind of see it. You just have to kind of lean over. Yeah.
all right. Anyway.
Yeah.
Oh yeah, I should just do that.
Yeah,
I'm
it's
sorry.
it's totally this
Instead of
little
turning
monitor
on.
we've got.
But you can see now
A
this
styrofoam
is,
planet.
Yes, they call it the styrofoam. This is an artist concept. We have an artist at Caltech who's with IPAC.
Yeah.
His name's Robert Hurt.
Excellent.
He's a very famous artist, and he does a lot of these for us. And we throw them in. When he does one, we put it in right away.
That's cool.
So, so there's the styrofoam planet.
Yeah.
Let's see what the next one is. So down here.
Oh, there's like a paging down on the
yeah,
bottom. We can see that. Yeah, you can see that on the stream. Good.
Right? So this one is must be. This is one of the strangest.
Okay.
What does it say about the thing? I think it's the 2.2 grams per cubic centimeter. Defy current gaseous pressure.
Wow. It's so. This one says it was so light it would float on water too.
You know, I'm starting to wonder about
If
that.
it updated, yeah. Actually,
yeah.
is that the one
So
from the
let's go
last
ahead.
one? Because that does say large and lightweight.
Okay, well, look at this one. This
Yeah,
one's
here we go. World of Two
notable for
Suns.
its likeness to the planet Tatooine, Star Wars fans, because it's got two suns.
Ah.
All right,
In a binary, so you can see the suns actually orbiting
suns
themselves
are
there,
orbiting themselves.
and then the planet would be orbiting the common center of the
Exactly.
two
So let's
suns.
compare this with our solar system. Has a different plane of its ecliptic.
Oh,
right?
oh, it actually does that too.
Yes.
It doesn't just like
No,
level them
if
off
we,
together.
If we do what we can in terms of keeping it real.
Gotcha.
Now I wonder. Let's do a star view.
Then y'all, we do have again. We're basically night at the museuming it here. We're after hours at the museum, and they're cleaning some things up. So if you hear some noises in the background, it is equipment that's moving some things around for the evening. So that's what's going on in the background.
It's all right. And there they are. Okay.
That's
So
cool.
I'm curious if we say habitable zone.
Oh, it's right on the outside of the habitable zone.
Yeah, it makes it. And then let's see what it looks like.
A lot of gas giants out there, it seems.
There's a lot of gas out
Yeah.
there. And then there's the two stars. Now I'm going to go ahead and speed up time. So you
Oh wow.
let's see if we keep
Can you imagine the sun's moving around in the sky like that?
That'd be awesome. Right?
I think we'd have some pretty sweet myths if
Yeah.
that's what we were dealing with.
All right. So there's that ability to look at the extreme.
The extreme planets. I've got to go. That surface view that you had.
Yeah,
Can
you
we
wanna go
hop back down to that
Absolutely.
surface view?
Let's do it. Let's go back to the view from Earth.
Yeah.
Where do you want to view from?
Just wherever. I mean, someplace that's dark.
Again, let's go ahead.
There you
back
go. So we can see where the nighttime is.
How about Cairo?
That's looks
Near
nice,
Cairo.
nice and dark.
All right.
So the thing that got me with this
Yeah.
was, I used to go outside and you look up at the side and there's all these stars in the sky, right?
Right.
And you're like, wow, especially if you can get away from like the city, you get out where there's not a lot of light
yeah,
pollution, and you kind of look up and you can see the Milky Way and you see all these stars. We always thought that there were other stars that would have planets around them, but it's not normally when you look up what you think about. And
right.
now, next time I go outside and I look up in the sky, I'm not going to be seeing stars, I'm going to be seeing places that might have planets.
Yeah.
It's kind of a testament to the technology that lets us go out there and look for and search and confirm these planets being out there that kind of pushes these things forward.
Now, what was fascinating to me about the press conference was
Yeah.
here we had some of the most foremost exoplanet scientists.
Yeah.
And the bottom line is that they will tell you now, when you look up at the night sky and you see a star, it has planets.
It has. It's
And
odds
I
on.
would say the odds are way in the favor.
Yeah.
That every star, or almost every star, has a planet.
Wow.
Here's that one had 7.
Yeah.
Like I said, ours has 8. They're out there. So anywhere you look in the night sky, there are other worlds.
No kidding.
So that is so cool. And the nice thing is we are right at the beginning
Oh,
of
yeah.
exploration of these
Oh
things.
yeah.
And it's like the golden age of exploration for these.
Absolutely.
And it's just exciting to see where we're going to go. And again, we are building ways to image
Yeah.
the actual planets so we can see what they look like.
Right, with the occlusion where you'd block out the light from the star and be able to look at the.
An important thing here. So you notice we talked that we found a Trappist one that has
Right.
7 Earth-sized.
Okay.
But I want you to notice Earth-like planets. Look at the number.
Ah, it says 0.
0.
Okay.
So, and there's a debate in the community
Yes.
about how do we characterize a planet as Earth-like.
Right.
Obviously, the people that are winning that debate now are those that believe you, in order to say it's Earth-like, it's going to have an atmosphere
Right.
whose chemistry we can recognize.
That makes sense.
All right?
Yeah.
So I was told that's about 10 years away.
Okay.
Right.
Before we have the sensing
But
capability.
there are others, like, for example, there's another display that has, at JPL, that has Earth-like planets. It has like 3 or 4.
Okay.
So the group that controls that display has a different theory.
So
But I love
in
it,
their
right?
part of the building, they
they're-
can put up the sign that
They're
says.
part of the lab. That's what they say. But the folks that we work with at the next site,
Yeah.
at Caltech, right? They are sticking to this, and we're sticking with this as well. There's many Earth size now.
I like that though.
Earth-like.
Like
We're waiting. When that number hits 1, then that's like, oh boy.
that's
we've
going to be
got
big
it.
news.
It will be for me.
Yeah. We know it's got to be out there.
It's out there.
There's too many of them. Right? Like statistically.
Statistically,
We just have to find it.
Statistically, there's all kinds of folks out there looking for us.
There you go.
It's like, it reminds me of that first the first Star Trek film with V'ger.
Yeah, when it comes coming back home.
Yeah, you do it. In fact, I
Excellent.
wonder- No, we don't have a Voyager.
Yeah, we're on the exoplanets.
Exactly.
So to get to the other one, we'd have to go to a different.
We'll switch.
Yeah.
But that's okay. So you can view from the Earth.
Right.
Now here's kind of fun. These are the latest
Latest
discoveries.
discoveries.
So these are different publications. Now this is not as up to date as I'd like it to be. Otherwise, we would have Trappist 1 in here.
Okay.
These are the Kepler discoveries because it was the main mission.
Yeah.
Oh, and you can do this. So here are the discoveries. Let's turn off those that are confirmed. Those will all go away.
Okay. Might give it a
Just go away,
second
come on.
there. Is it going away?
Oh, come on.
Close.
Oh, you know
Maybe
what?
click on
not.
something else. Yeah,
just click on
candidates.
just candidates. There we go.
That should be a radio button.
Yeah. I
Feedback for your app. That's a radio button, not a checkbox.
agree. So these are the candidates. All right. Look at those. Candidates.
Gosh.
There are 2,244 candidates.
Right.
So both are 39.
Oh, that's the whole. Oh, wow.
That's just the Kepler.
So confirmed is confirmed stars that have exoplanets. And
Absolutely
candidates
confirmed.
are stars that we haven't looked at enough.
We haven't confirmed. I think the requirement is there has to be a jury paper written about that.
Okay.
So that it's been reviewed by the
Yeah,
scientific
somebody
community.
actually goes in and instead of just having a computer say, well, here's the stuff that falls on these parameters, somebody actually reviews it and kind of.
Absolutely.
Gotcha.
Okay. So those are both, right? Go back
Yeah.
to confirmed.
Gotcha.
Confirmed Keplers are 1711.
Yeah.
Candidates are over that. There were 2,000.
So there's even more. Yeah.
more candidates left, and then both is massive. And they predict that most of these will, in fact, be confirmed.
Gotcha.
It's cool.
That's cool.
right.
Could we maybe open it up to a couple questions
absolutely.
about the Eyes on Exoplanets things here from
do it.
chat? Chat, let me actually switch back over here. Unfull screen is this right here?
Mm-hmm.
Okay, cool. And that's going to let me get back down to here, and we will hop over to here. So guys, we'll actually take a couple questions here. You know the drill. If you have a question for us, start your question with the word question. That's going to highlight in chat over here, and we'll go ahead and bring the thing back up. Some of the science stuff, like, oh, Das, do you think that there's going to be aliens or something out there? I might skip over some of those questions. Let's kind of focus on the app and maybe questions on things that you can look for, things that you can do in the app itself, as opposed to hypothetical, when are we going to find green men sort of stuff. If you guys could help me rein those sorts of things in, start your chat with the word question, then put a space, and then put the rest of your question. I'm only going to be reading things that start with questions. So go ahead and put some things over there in chat, and we will see what we can answer. So let's flip back over to the eyes cap. Back to here. We'll like that. All right, so let's see. Question. What is your favorite planet to view? Do you have a favorite planet in your app to view?
You know,
It's a good question.
Yes, actually I do, and it's one that's in Trappist 1, and it's the one right before the habitable zone.
Right.
Let me show you.
Yeah, go. You can go there, right?
I love this planet because it has both. Oh, I'm sorry, I lost my mouse.
Yeah, there you go.
So I'm just going to do the simple way. Say go home.
Yep.
Going to go here to the system of
You got
7
the shortcut.
planets.
Yeah.
Throw up my habitable zone, and then the reason I like this one is it has land and water. You'll see it here. It is right inside. It's Trappist D. There's something about this particular. I just love this thing.
Right.
All right, because this is the side that's tidally locked.
Yep,
to the
tidally
sun.
locked again.
Of course, you've got your nice desert scape, if you will.
Yeah.
And then here you've got an ocean in between. Let me turn the light on.
Like a Twilight Zone sort of
and then
thing
look,
in between.
You've got an ice cap.
In the ice, a big ice cap.
Yeah. So you've got again ocean, land. You asked. That's my favorite.
There you go. That's awesome.
That's my favorite. I wish it were in the habitable zone, but hey,
Nice.
it's close.
Let's let me get some more questions here. There's a favorite Venice. Was there a way to zoom in on different places? I mean, you could just basically, it's all a click interface, so you just click on different
I'm
things,
just
right?
scrolling back right now on
Right.
the wheel. I keep scrolling out. In fact, I'm just going to keep scrolling while we're talking. So
Yeah, that's
scrolling
fine.
out. Or over on the right-hand side, there is this bar.
Yeah, the slider, so you
Slider.
can slide it up or down.
Either way.
Excellent. And if you want to zoom on a different planet, you just click there,
Just
right?
click there. Anything you click becomes your focus for an orbital camera.
Gotcha. Excellent. Let's see. Zoom in. Is the source code for the exoplanet database available? Like, is the source data publicly available?
The
We've got a lot of programmers that watch the show,
Yeah,
so.
I'm almost positive that you can get the database that's at Caltech, the same one we use.
Right?
I'm not 100% sure, but over 90%.
Okay.
It's public
It's public information. It's just is the interface
yeah.
to get it there.
So
yeah.
how would I could check on that. I'm almost certain, but I can't 100% say.
Yeah. Is there like a generic email, like a help@eyeson
Yeah,
or something like
you
that?
just do it at eyes.nasa.gov. On the website itself, you can scroll down to the bottom.
Yeah.
You see my name, click, send the question, I'll get an answer.
Gotcha. So eyes.nasa.gov, there's a way you can get in
eyes.nasa.gov.
touch for questions
Bottom
like
of
that.
the website, there's a link to either I'm not the webmaster. Actually.
Yeah, fair enough.
That's what they called it. But either myself, my producer Jason, or
Yeah.
one of our programmers will answer.
Excellent. So I can actually field a couple of these. Can you see where the Voyager missions are? Right now we're in Eyes on Exoplanets, and there's a different sort of setup for Eyes on. Would that be the solar system?
It's
or
Eyes
is
on
that,
the solar system.
It's Eyes on the solar
At
system.
some point when we're done, we may go there.
Yeah, we're gonna have to switch apps and captures to hop over that one. So
I'm
we'll
gonna
see if we
check
can get
something.
there.
I don't think so, but I'm scrolling in because there's Voyager. Now let's see if it's clickable. Oh my gosh, here we go.
Oh,
There we go.
wait, it isn't here.
It is in there.
Oh, there
And
you go.
And it's actually this location right now.
So yes, you
There's
can.
Voyager. I wasn't sure because sometimes we turn them off depending
Yeah.
on. There's Voyager.
Yeah,
And there it is.
There it is,
There
right
you
there.
go.
Leaving the solar system. Excellent. There was one that I wanted to get. How do you know what color to color the planets? Like, is it based on like spectral analysis of known elements coming through the atmosphere, or is it?
We don't have that much information.
Gotcha. So we're not quite there yet.
We're not quite there yet. The way they're colored are, first of all, based on its density, its mass, its size,
Right.
and its distance from its sun, we know if it can exist as either a gas giant
Right.
or a rocky planet.
Right. Based on the temperature and the energy coming from the sun.
And then based on those parameters, if it's a gas giant, we will just assign it a color and a certain texture. So we have 3 or 4 textures.
Right.
So we mix them all up. So basically, hypothetical.
Right.
The only thing that's not is whether it's a gas giant or a rocky planet.
Right. But we're not up to the level of all right.
No.
This sort of wavelengths come through it,
Not
so we
yet.
covered. Not yet.
We're dying to get there.
Not yet. We're dying to get there. That's what I like to hear. Let's see here. Can it show known spacecrafts? Yeah, it can show known spacecrafts and
Yep.
comets and asteroids and stuff like that. What would the weather be like? I have no clue what the weather would be like on those.
Very similar to what it would be like on Jupiter if you're on a gas giant.
Okay.
Which is a turbulent,
High-speed
high
winds.
speed,
Yeah.
and just very, very tumultuous
Gotcha.
climate, I'm sure. And then, of course, if it's very close to its sun, you're going to have things like either Mercury or Venus or something like that.
Right.
It's easy to do analogs between the years
Sure. Absolutely.
because no one can check on us, right?
No one can check on us.
It's
Nice.
getting close to where we can get more information.
Let's see here, and I'm scrolling down, finding some new questions here. Are any of the exoplanets outside the Milky Way? So everything that we're finding right now are inside.
Yes.
Yeah.
In fact, let me show you where our search bubble is, if you will.
Oh, good.
We're going to go home.
Great question.
Now, we don't have a particle system yet for the Milky Way, so I'm just going to scroll back.
Sure.
Give you an idea. So this is only in the Milky
Wow.
Way, right? Let me see. Unfortunately, I wish I had a 3D, but it's plain right now.
Yeah, no, it's fine.
Apologize for that. Hey.
No, but it gives you the scale. It's like,
But it
oh,
gives
look
you
at
an
all these
idea,
awesome
right?
stars, and then you
When
zoom out.
I accidentally clicked on one that's closer. Oh, check this one out.
Look, don't go to the core. It's a boring place.
Look at that. Look at the. Wow. I think that's the farthest side.
Yeah.
See how far this. Look at that. 25,000.
25,000 light years towards
away.
the center of the Milky Way.
Yeah. Yeah.
But everything here
I gotta
is.
compare it. I gotta compare
You got to
those.
compare it. There you go.
All right.
That exoplanet is right there around Earth.
Here we go. Ooh.
Whoa!
So it's going to be a while before we talk to these folks.
Yeah. Can you imagine what the night sky would look like near the middle of the Milky Way, though?
Oh my gosh.
That would be
Fun to imagine those
crazy.
things. And then again, it's a gas giant. We have no clue. Well,
Yep.
It's pretty.
Yeah, it is nice. I like the colors. They're nice pastels. Let's see here. And I'm going to keep on scrolling down and find some more questions here. Well, guys, there's so many good questions. As always, there's no way we can get to all of them. But there are tons and tons of good questions here. When we go back to the other camera, remind me, I owe you a high five. Someone asked if I could give you a high five for being awesome.
Thank you.
Let's see. Scrolling down. Yeah. Okay. I think I'm good. What's the rocket button at the top do?
Rocket, that shows you the planet finders.
Okay.
So just so you know,
So the different spacecraft or missions.
we are going to remove the space station.
Okay.
As we don't have any confirmed exo from the space station.
Well, tell them to get on it.
Yeah.
All they do is like work out with rubber bands and take pictures of Earth. Come
All
on.
the other ones have found them. In fact, what's kind of fun is under the search bubble now,
Yeah.
we added a capability which is by observatory. So you ready?
Okay.
Click this, and now here are all the places that have found.
Oh wow.
Right?
So it's not just the things that are in orbit that are finding these
no,
things.
We found. So for example, Trappist 1.
Yeah.
It's named after the observatory in Chile.
Okay.
Run by the Belgians
Okay.
that found 2 exoplanets.
Wait, it's run by the Belgians.
Yes.
I thought that it sounded like a beer.
All right,
I think
so
it's like a Trappist
I got
ale or something, right?
Funny story about that. So one of the questions that was asked at the press conference
Yeah.
is, do these have better names, or these have names? And the guy said, well, we would like to name them after Belgian beers.
Nice.
But we have not been allowed to do that. We're going to come up with a way to name them.
Aw.
But I like the beer idea
Yeah,
myself.
I like the beer idea too. I mean,
But here are all the different places that have found, and then if you click on one, so let's see if we can find Trappist in here.
yeah.
Where is it? You think it better be on here?
Oh, I don't see it.
Uh-oh.
Who made this program? Can we talk to them?
Yeah, you know what? Maybe we put it under the name of their observatory.
Yeah.
I'm sorry about that.
Chat, can anybody paste into chat the name? Is there TRS? That starts with a TR. I don't know what that is actually.
no
So,
idea either.
does anybody know the name of the observatory?
It is the Trappist telescope.
Okay.
But if someone could check that out, I'd appreciate it.
That's the great thing about this, because we can give them something to do,
I-
and we'll go out and they'll find the answer for us.
I appreciate that. But okay, so K2, that's the second Kepler mission, the one
Right.
I saw.
Yeah,
so
yeah,
if
yeah.
we click here, we now are going to see just those that were discovered on the secondary Kepler mission,
Okay.
not the primary. Okay, so we're calling a different mission. That's why it's there.
Yeah, gotcha. And so they're kind of grouped separately like that, right? Yeah.
And then there's the Kepler original, right? Gosh, I wish I knew the name of it.
Yeah.
I guarantee you it's in there.
People look, hop on it, chat. I'm not
Simon.
seeing the answer in chat yet.
Okay, and then, well, you get the idea. So here, how about the Anglo-Australian telescope? Let's see what they found.
Here we go. It was the ESO La Silla Observatory in Chile.
Beautiful. Let's go find it.
La Silla, right there.
Ta-da!
Yeah, Twitch chat strikes again.
And you will see.
Let's see. Is Trappist in there?
Pots.
So maybe it's not.
Hang on.
Yeah. It's one
Well, that one's
planet.
way out.
It's got a 1 on it, so. Oh no, it's going to be close to
So there's
us.
136.
Yeah, yeah, it's
right?
gonna
So
be
we
close to
getting
us.
Closer.
I see a
Let's look for
3.
one. This one's going to have 7.
Yeah.
Oh, come on.
Problem with that game, though.
In fact, let's just do this. See how far this is.
Center of gravity.
So that's 14.
It's
Let's-
14,
let's
so you can kind of
work
get a
out
scale. There's 50.
55. So it's in this zone here.
I see a 5 up there.
Oh.
It's like a wait.
Oh, that's a 1.
It's like a word search. It may not be listed under here.
Oh, it should be here. For crying out loud.
I see a 6 out there, but I don't see.
Where's the 6?
Oh, well, the 6 is
That's too
way
far
out
out?
that way. Yeah, that's too far out.
Let's do this 5. No, that's not it.
That's definitely not it. Yeah.
But you know, one of the fun things about doing this kind of thing and giving demonstrations is I find things that are odd.
Yeah,
that need
absolutely.
To be investigated. And if we had more time, I believe it's there. Of course,
It will be next time we bring it up, right?
absolutely. In fact, David, if you're watching,
If you're watching.
please. Why isn't that 7?
Why is that not there? We are live here.
Yeah,
and-
we know there's 7 out there, man. So let's go to planetary system view. But oh, you know what? Let's approach this a different way. So
Okay.
let's go back, and let's go back to by name. Go ahead and type in Trappist again.
Yep. IST. Wait, did I get it? Yeah, I got it. And then go.
Go. All right, and then
There's
let's do the
Trappist.
Trappist 1 again. Let's take a look at.
Let's
There's
read just
7.
more information or something.
I want to look around. Oh, I think he turns off the other one. So
It's a 3D ultra hard fun time word search.
yes, we're going to look for
In
that.
space.
But it will at some point. I would say very soon.
Yeah.
There'll be a 7 bubble out there.
So there'll be a 7 bubble out there. we know the people that are in charge of this, I
actually know
think,
the
right?
guys.
Yeah,
Name
you
is
know the
David,
guys.
yeah? So,
Excellent.
All right, so that was a search there. We asked about this. Those are the missions that find them.
Right?
These are the tools. We have other things like you could change to just a little dot.
Yeah.
If you don't want the big
Yeah, you
old
can change the
Christmas
different
dot, right?
icons and stuff.
There's
Yeah.
just 3 choices there. You can also, the grid.
A grid.
Oh, this is cool.
Oh, what is that?
So there's a grid going from the sun.
Yeah.
This is kind of fun. That allows you to show. So there's a light day.
Oh,
You see that Voyager 1.
it's like range rings.
Yes, yes, exactly.
Ah.
Right? Let's see. Let me go back. I got to go back to my other.
Yeah, sure. Our preferred labeling system
I'm
for the
sorry.
stars.
Let's keep going out. So there's one light day.
Yeah.
There's a light week. A
Light month. And 1 light year. Oh, there's a big ring.
Right? Light year. That's so you can see it when you
Yeah.
keep going out.
Now, is that one that we just went by? Certainly, that's not. That one right there. That's 4 light years from Earth. I just saw one scroll by and I
That's
was
all
like,
right,
"What's
that's
that?" And then this is like the Wikipedia of space visualizations. You just keep clicking on stuff,
Yeah.
and like 3 hours later.
Right? So you can keep going. Just keep scrolling back.
Yeah.
But the grid. Okay, I just want to.
Yeah. My bad. I was just-
That's all right. That's all right. And then you can go to now brightness. Now sometimes, like for example, this software you can see it.
Mm-hmm.
It's now in the Air and Space Museum. There's a kiosk there that has the software.
Right.
And at different museums, depending on the ambient light, you may want to change the brightness of the stars.
Okay.
So you can see.
Oh,
them
I
go
see.
Up, down if they're blocked.
So you can actually turn them down and just what's like. I
Exactly.
see.
So you can show the grid. You can turn on and off labels.
Yeah.
Or if you want to turn the star field off,
Ah.
right? It really turns down a lot of them.
Yeah, the
so that
background.
when you go back to home, you don't get confused with
The little
others.
white dots versus the
Exactly.
things that you can actually click on, because the white dots
Yeah.
are like a background thing, right?
Yep, exactly. But
Gotcha.
They are part of the Hipparchus catalog. and,
Yeah. They're real things. It's
They're
not
real
like,
things.
oh, we just put a skybox there.
they're there.
Excellent.
All right.
Excellent. So is there anything else in Eyes on Exoplanets we should look at
Let me see.
here?
Oh, there is if you have anaglyph glasses,
Ah.
and view it
Whoa.
in 3D, which is pretty trippy.
Wow, that is
right?
pretty trippy.
Just need a pair of cheapo glasses.
I actually have a set of those sitting on my desk at the studio. I could go into this and just like put them on.
I brought a couple thousand here to give away to the kids. So,
Oh, really?
yeah, so I've been giving those away. People, in fact, that's how I can attract a crowd.
Yeah, it's like, hey, free 3D
As soon as I put those out, people see people with glasses on.
Yeah.
It's like a magnet.
And they say
People
NASA on
love-
the side too.
Yeah,
It's
they-
like
they get NASA
they're not
glasses
just
now.
3D glasses; they're NASA 3D glasses.
So basically, this is kind of it.
Yeah,
You know, we've run through those.
that is cool.
And then there's this other button over here.
Okay.
We've added this button here, which takes
That takes you back.
to the main menu.
Yeah.
So can I do that?
I
Or
don't
you
think that
wanna
it's
ask
going to
questions?
capture. I don't
Okay.
think that it's going
All
to
right.
capture if we do that.
So I can answer more questions.
We can
or
try to give it a
see what it
shot
does.
there.
So how did thing go for you?
Oh, that's right.
Yeah, that's just going to. Hey, we're checking for updates.
Every time we launch this, we check.
Oh,
for updates.
we can broadcast that.
All right.
Yeah, we can show that. So this is kind of the chooser screen or something,
Yeah.
right?
And then you go ahead and click on Advanced Eyes on the Solar System.
Advanced, right here. Advanced Eyes on the Solar System. There you go.
We'll load this up.
Show the other screen. Yeah, sorry about that for the jump there, y'all.
And then there's one thing in here I'd like to show folks. I think they'll get a kick out of it.
Okay, we probably have time for one thing.
All right.
How do I go full screen here?
Full screen?
Yeah, you got it.
That's right. We give you a hint. Let me get this right here.
There it is. All right.
All right.
And I'm just going to confirm that we've got that coming up. That should come up. I just wasn't set up to do that one.
Now, watch under Tours and Features.
Okay.
We have built the Eclipse 2017.
Ah.
So when you click on this, we're now going to load the information about, I call it the Great American Eclipse of
Right, because it's going all the way across the United States about, right?
And what's neat about this is you're going to be able to visualize.
Yeah.
I thought I clicked on it.
I think you did. This is going to zoom us in, or?
Oh, here it goes. It's just taking its time.
Yeah, there you go.
We'll say Explore. So this is set up specifically. Oh, get away! What's this? What are you doing? Oh, I screwed up.
Too many clicks. Too many clicks.
Backwards. Yeah, I'm sorry.
No, that's okay.
Now the question is.
That's my bad for the weird window changes that hop back and forth. There you
now
go.
I'll leave it alone.
Now just don't touch anything. You just let it go.
I'll let it do its thing.
Yeah.
It came up and then I killed it.
Yeah, it came up for a second. Yeah. It's all good.
But I think this will be worth it because what this will allow you to do is to visualize what you're going to see from anywhere on the planet.
Okay. Wait, what you're going to see?
What you're going to see from the ground.
Oh.
So I'm going to go, first thing is I'm going to go ahead and slow down to 1 frame per second.
Right.
Then I'm going to come over here to the screen and I'm going to say boundaries map.
Right.
Come on.
Chug, chug, chug.
Hit it again.
There you go.
So if you live in this zone right here,
right,
or you have a friend there,
okay,
you're going to want to visit them. So here we are in New York. So let's start with New York. Click on New York. That is what you'd see in New York at 12:39 p.m., which is nothing. So you grab the time slider.
Right. Oh, and that's why it's not a complete eclipse, because a little bit of it, and that's what it shows over there.
That's what you show over here. Okay. But now, if you're in, for example, if you're in Los Angeles during that time, it's just starting.
Right.
Or actually just ending.
Right.
Houston.
It shows you exactly.
Kansas City,
wow.
Vancouver, or custom. You enter your own.
You can just put your Latin lawn in there.
Now you can do this. Let's say the folks in Venezuela, southern Venezuela.
Right.
Put a pin there. Gee, yeah, they're not going to see it. Yes, they will.
Oh, at a different time.
Right? So this is something, like I said, if you have relatives that live anywhere in this zone.
Like in Nashville right there. Man, Jefferson City would be great.
You could grab the moon too.
Ah.
There you go. They're going to have, their eclipse will be at 2:28 p.m. Eastern time.
Wow, and it just tells you exactly what time it's going to be.
What it is.
It's like family planning, you know? You can like figure out when you're going to go on an outing. Could we click on Lansing right quick?
Lansing, absolutely.
And you can just click on the map and it'll show you that location, right?
So Lansing, Michigan.
The edge over that way, yeah. There you go. And then you can scroll back and forth and you can see exactly the time and date and what it's going to look like.
Exactly what it's going to look like. So we had a lot of people here in the museum from the UK.
Yeah.
So they wanted to see what they could see from England.
So you're going to show them what?
So what I did was I came over here and I said, gee, it doesn't look too hopeful.
Yeah.
So UK, sorry, but check this out.
Wait.
In Ireland, okay, you can go ahead, little clips. just a little
corner. It's just going to clip the corner.
You know?
Nice.
So anyway, have fun with this.
Excellent.
There's a version that we're making that works on WebGL in the browser.
Okay.
So
you have to download it.
And you go to the Clips module.
Right.
You'll notice that there's on the right-hand side, it's in a beta version right now. So that, but you can go to this beta version, and it will work inside a web browser.
Okay.
And we're going to show the celestial mechanics, so you can see the Earth, Moon, and Sun along with the Earth. Okay.
Is there a mobile version?
That works in the browser on your phone.
That works in the browser. Okay, gotcha. Yep. All right, so there's not like an app you download from the App Store or anything.
In the browser, it'll work.
It's just in the browser.
Android,
gotcha.
Or excuse me, it'll work in Chrome.
Okay.
Or Safari. I've tested it on my iPhone.
Yeah.
And we know it works in Galaxy tabs.
Excellent.
Chromebooks.
Excellent. So that's the same exact website. The eyes.nasa.gov is where you can get it.
You go and you click on. There's a big tab that comes up on the bottom.
Yeah.
In fact, right after that triple window.
It kind of hits you in the face, right? It's like, hey, you can't miss it.
And then the main one is the one I showed.
Right.
But if you look to the right, you see a little ad because we don't want the whole world getting on it.
Right. It's not. It's available, but it's not all.
But we haven't like fully advertised it because we've added the ability to look from the Earth and Moon view and the Earth view.
Right.
We're going to do an Earth, Moon, and Sun view.
Gotcha.
It shows you the entire solar system, our Earth, Sun, Moon system. It shows you the mechanics of why we're having an eclipse during this year. So you can see how the plane of the
Oh,
ecliptic changes.
gotcha.
It shows you the whole thing.
That's pretty
That's
cool.
coming up.
Is that just in the web version, or is that in
That
all?
will just be in the web.
It's going to be just in the web.
Yeah.
version. So get both.
Yeah.
Well, excellent. I think we're starting to get to the end of the broadcast here. And I know that we are kind of closing down the museum. So I'm supposed to high five.
High five.
Yeah. There you go,
yeah.
Popsky. High five to Kevin here.
Almost an
Kevin,
hour.
thank you so much for spending time to come over. And y'all, again, we're at the KidsWekk here tomorrow from 10 a.m. until 5 p.m. If you're within striking distance in New York City, come on out and visit us. You have a booth, a little
across
sort of
the
set
way.
up over that way.
Yeah.
And you'll be here tomorrow as well?
I'll be here tomorrow, and I have a 6-foot diameter magic planet.
We could actually
The eyes
show
of the
that on the
Earth
screen. Watch this. Here, let's
over there.
see.
It's a little gray now.
It is gray, I think. It looks like the moon, but oh, EJ. I think
right behind EJ.
oh, it's turned off right now. Yeah, wait, EJ's gonna go. EJ, go hold that thing for us. There you go. Totally night at the museum here. Sarian's there. The Sarian wave. Brimo's here
There
too.
he is, right
there you go.
in front of
EJ holding it in the background. Excellent. So, Kevin, thank you so much for spending the time.
It's my pleasure.
Excellent. So, guys, again, we will be here tomorrow as well. We're doing the interactive exhibit from the Sea, Air, and Space Museum in New York City. If you can make it, stop in. If not, we'll have the stream up again tomorrow, hopefully from 10 a.m. until 5 p.m., playing some Kerbal with the people and family and kids and stuff that come through. So, again, thank you guys for all the support. Thank the Intrepid for inviting us out here and letting us have the spot. And we will see you nerds later. Have fun for now.